Hello everybody, welcome. Today, meaning 5 minutes after I finished my previous video, I'm gonna show you HP UX OpenGL's demos. Everyone knows the SGI demos, they are very well documented, but almost no one documented HP ones. Maybe no one. So let's get to it. So HP, if you saw the graphic packages, gives you a list of demos covering different platforms. So for example, unfortunately, my GPU only runs OpenGL. I'm looking for a different GPU in the market, right? To see if I can try Figs and Starbase and so on. But at the moment, I have a FireGL, it does only OpenGL, and this is what we have, yeah? And it's going to be very hard to actually find a GPU that supports the old APIs, but runs on the C8000, because unlike previous HP workstations, this one has an AGP slot. You get to it. You get some wow, you can register. HP visualize impressive environment. Well, whatever. Close. Goodbye. Let's go to the demos. All right. To begin with, we come with a few executables that are for some reason broken. Yeah. So, for example, if I go verify UID32, cannot run, right? 64 cannot run. The file. This should be. No, it's not an executable. But anyway, for example, if I do verify 32 here, it works. But for some reason, even though my machine is 64-bit capable and I'm running a 64-bit kernel, it doesn't run, right? So, for example, right, I have a problem with, it's basically a C problem, yeah, it's a compilation problem. Maybe it's something with the new GPU or new HP UX, I don't know. But 32-bit works. So this is what we're gonna use. So verify install just opens this cool, pretty colorful box. If you go to help, there's nothing. You can rotate the scene, right, and make it slower or faster, just like we have with the SGI workstation. Let me try to get it rotating a bit slower. So you can click and too much. Yeah, that's better. And then you can see this is a very simple demo, right? Ah, the timing is not tied to seconds, but to processing time. It's quite funny, right? You can zoom in and out with the middle mouse button. All right, classic, just like the SGI demos. Yeah, so now it's closer, further away. What does the right button do? Probably nothing. We can leave this here for now. All right. Now let's see. Let's try verify new word 32. Oh, that's what I just have running. Verify this center 32. Yes, so for example, you see the version of OpenGL I have does not support the center functionality. And I think this is related to the graphics card. So we are not going to see it. Let's try the next one. So let's go to core. Occlusion collision. So let's try again. I think this one I compiled. It is cool because you have the C code, and I do intend to run it in other systems. So let's go to OC complex 664. And again, 64-bit doesn't run, but 32 bits runs. And again, we have a model. This is very engineer focused. And for some reason, it's much slower than I remember. Now points to the SGI. Yeah, so let's stop the viewer. Yeah, exactly. Now I stopped the rotation movement and the frame rate reduces. Point to SGI. What we can do here with this occlusion Q, it's not occlusion collision, it's occlusion queuing. So it's running at a lot of frames per second. The viewport is not proportional, so it breaks when you expand, which is fine. We can, and look at this pop-up menu, looks like this, guys. You can disable occlusion queuing, which means that I don't know what this exactly does. Yes, I think it's rendering even objects not on the screen. Right? I don't know why it reduces the frame rate though. You see, it rejects polygons. Visibility test. So if I enable it, so now I don't know what this is doing. Anyone who understands the 3D, please show me. Can show the bouncing boxes here. Can hide them, and I can remove the shell and show what's inside the model. Can I zoom in? Probably not. I can make this bigger. And so you can see inside the model. This looks like this is an electric screwdriver. And we can let it running, or we can stop it. So now I don't know if it's a problem with the OpenGL implementation or if it's the GPU. It's probably the implementation because this card is far superior than anything SGI has put in the market yet. Click the book here. See, when I'm clicking and running, it reduces the frame rate and moves the mouse more. Right. Let's try OC simple. Maybe this is going to explain us what it's to do. Come on. So occlusion testing enable visibility test passed. The test doesn't work properly when the system is overloaded, and you see the difference in speed. This is a question for our experts. And if I disable occlusion queuing, it's smoother, but it's not testing anything in bounding boxes. Anyway, I know as much as you do, or probably less if you're my viewer. Let's try another one. Chess. Chess is very nice. Again, we know that 32 doesn't work. So 64 doesn't work, so let's run 32 bits. I want to build this in other platforms as well, just to exercise my programming skills. You have the traditional chess clock here on the top. and you can play with the machine playing blacks or whites. Machine can play both, right? So you see the computer starts playing here, the game, and the animation is very fast. Yeah, I believe in a slower system it would be slower, but if I move the mouse, you see the pawn. And there's a perspective change here. As you can see, my mouse cursor is not matching the pawn all the time. Here, for example, the clock starts turning. I can show the rendering stats. Don't know where. Aha, I can rotate the board. You can see the reflections there. I can zoom in and out. Let's put the computer to play both. If we look at the texture map, it shows it for us. Right, quite pretty. Can disable the reflections. Can disable reflections and texture map, but I can add shadows, which don't seem to make effect if you don't have the reflections on. So let's turn reflections and texture map back. Now let's see, wireframe. Well, it's classic wireframe here. Runs very smoothly. The card is super overkill for this. Smooth shade. Aha, it smoothens the models. There's some options here. Adjourn a board, so basically all the chess commands and visual info. Then you get information about the OpenGL renderer, yeah? Good, that was chess. Next one will be stereo, probably not gonna work because I don't have the stereo goggles connected. And I probably didn't manage to make it. Yeah, anyway, I need to figure this one out. It should know what this is doing because the library path here is correct. I'll troubleshoot this eventually. Anyway, I don't have a goggle, so it doesn't matter. Let's try threads. Threads 36.4 is gonna fail, so let's do 32. And yeah, OpenGL is single threaded, so I don't know what the magic is here. I mean, of course you can, I don't know, I think OpenGL is single threaded, but how to use level 2 to OpenGL? So there's a main thread. Aha, so probably the render thread is, no, it's multiple render threads. What? How does this work? I'm not gonna bother with that now. Let's run. Let's see. Yeah, to finalize, let's put all the demos on the screen. Let's put the computer to play chess. First, let's do texture map, shadows. Now let's run the next one. Now the next one will be simple. And to finalize, the classic demo. I don't know why this one slows everything down so much. What's the deal with it? Maybe it's set to use as much. Basically, it just saturates the system. It's probably not doing any timing or anything. It's just running continuously. So, yes, thanks for watching. And I'll see you next time. I might have some more things coming with this workstation down the line. If I manage to find a GPU, I will run all the demos, and also I didn't manage to build some of the C demos and none of the Fortran demos. So I may try to get in touch with someone who's an expert so I can document this part of computing history. See you.